Just before we play the meeting, I'd like to draw your attention to the following. As a truly free and transparent monetary system, Bitcoin Cash will lead to more economic freedom and prosperity. Bitcoin Cash, a globally scalable cryptocurrency, is quickly becoming the most technologically capable electronic money in the world. Bitcoin Cash needs your support to build and maintain the software infrastructure that lies at the foundation of this innovative system. If you have or plan to have a business that uses Bitcoin Cash or relies on the success of Bitcoin Cash, it is wise to consider contributing towards the infrastructure necessary to keep Bitcoin Cash competitive and ready for world-scale adoption. If you simply want to contribute towards economic freedom and equal opportunities for the global population, now is your chance. Just head over to bitcoincash.org to make a contribution. If you would prefer to contribute in some defined area, such as sponsoring a protocol developer's work directly, providing testing infrastructure, or in some other way, please contact us at info@fvnidevsociety.org. Thank you.
Good afternoon, good evening, and welcome to the 10th installment of the Bitcoin Cash development meetings for 2019. I actually had to think about the year. We're past the May 15th upgrade, and we're going to start with some introductions and then run through the agenda. So on my top left, we have Mark Lundeberg. Mark, could you introduce yourself, please?
Yeah, I'm Mark Lundeberg. I'm a Bitcoin Cash developer working on mainly Schnorr signatures lately. I think that would be the main thing, I would say.
Okay. My top right is Josh Ellithorpe.
Hey, I'm Josh Ellithorpe. I work on a lot of miscellaneous projects like Cash Shuffle, BCHD, and try to just be a helper on many little side projects.
Thank you, Josh. Next is Chris Pacia.
Yeah, so I'm Chris Pacia. I work in Bitcoin Cash primarily on BCHD.
Right, thank you, Chris. Jason?
Hi, I'm Jason Cox, software engineer contributing to BitcoinABC.
Thank you, Jason. Fernando?
Hello, I am Fernando Pelliccioni. I am the maintainer of Bitprim node.
Okay. And Shammah, Chancellor?
I am Shammah, Chancellor. I've been primarily focused on removing the chain length requirement of less than 25 regarding child pays for parent, and trying to simplify the memory pool code around that so that we can open that up to longer chains and have a much faster mempool and mining code.
Thank you, Shammah. Antony?
Hi, I'm Antony, also known as Mangari, and I work on Bitcoin Cash stuff, mostly BitcoinABC focus.
Great, thank you, Antony. And Andrea Suisani?
Hi, everybody. I'm a Bitcoin Cash developer and primarily working on Bitcoin Unlimited.
Thank you, Andrea. That's everyone for the time being. We know we have a couple of people that said they were going to be late coming in, so we'll just continue on. I'm going to quickly go over the agenda for today's meeting. We've been through the introductions. We're going to go through a status of the various node implementations, and then we'll talk about potential items for the next upgrade. That will start with Schnorr for CHECKMULTISIG. Next will be NULLDUMMY. Following that will be minimal push in scriptSig. Number 6 is Sigops counting limit. Number 7 will be possible NW codes, op reverse, reverse op roll, op mul, etc. And number 8 is 25 unconfirmed transaction limit. And I think that'll be a discussion that's will happen with Shammah. And we will have additional items and questions as they come up from our audience. So we'd ask the members of the audience to please click on the Q&A box in the bottom, and any questions that come up, we'll get to them during the Q&A portion of this presentation. So, starting with the status of various node implementations, could we start with BitcoinABC? And top of my screen is Jason, so please.
Sure. So, as you guys know, we just went through the Bitcoin Cash upgrade on May 15th. There was a little bit of an incident, which I'm sure you guys have heard about by now. We're going to be publishing an incident report here in either today or tomorrow, kind of going over what happened. But basically the gist was there was a vulnerability that had been around for a while, and someone decided to exploit it rather than responsibly disclose. So for any security researchers out there, we do have a responsible disclosure policy. It's right there on the top level of the repo. We have a pretty nice policy, and we do provide bounties for these kind of vulnerabilities when they're found. So I do encourage people to responsibly disclose instead. But that said, we're here to start preparing for the next upgrade, and I'm excited to see what comes out of these discussions.
Great. Antony, did you have anything to add from the BitcoinABC side?
No, not really.
Okay.
You pretty much covered it.
All right. Moving on then to BCHD. Which one of you two gentlemen would like to take that?
I can do it. Yeah, so BCHD also had a little bit of an issue with the hard fork. There was that 2-block or not the hard fork itself, but that 2-block reorg that took place worked some of our nodes. It looks like the nodes that didn't actually see those blocks first, that didn't have to do the reorg, they just continued on like normal, but the ones that had to do the reorg, there was an issue rebuilding the UTXO set during the reorg. And I think the issue was it marked some the height of some of the UTXOs incorrectly. Like I think the UTXO data itself was okay, but the height was off. So we have a new release out for we're version 14. So I'd encourage people to run that one instead of previous versions. And we did I did a good amount of testing with that, with the specific reorg blocks that took place. So I gathered all the raw data for the blocks, and then the new BCHD is correctly building the same UTXO set with and without that reorg. So it seems to be pretty solid now. I think that's basically it. There is, in the current version, there is a bug with the get block template code. I mean, not that anyone's really using it with mining, but we'll probably have a new version out that fixes that. And the only other thing, I mean, so the only reason we even figured that out is because I think Checksum0, I think his name is, wants to use this for mining, and so he's uncovered a couple of bugs in mining that we never, because nobody's ever really tested it that way. But digging deeper into the mining code, it looks like BCHD is like the only implementation that actually still has the free high priority transactions, like a block of space. It's like 5% of the block space reserved for free high priority transactions, which I think is something the other implementations said they want to do, which is BCHD already has it implemented. There is maybe a little of an issue there as it relates to zero conf not being having the exact same rules as everyone else. But as I said, I think it's just one solo miner that is experimenting with BCHD at the moment.
There's one small thing I'd like to add.
Get a little feedback from Chris there, I think.
Mm-hmm.
Go ahead, Josh.
So, oh, Chris, okay, there we go. So there was an issue with accepting Schnorr signatures into the mempool for people that are running their own node. That was also fixed. And so if you were running BCHD tied to your wallet, like the Neutrino wallet, it's advised that you update to the latest release, and it fixes that acceptance code. And Neutrino is now signing with Schnorr by default.
Okay, Josh, anything else to add from BCHD?
No, I think that's about it.
We're good. Okay. Move on to Bitcoin Unlimited. Andrea?
Well, the protocol upgrade went good for BitcoinABC. No bugs to report. Everything went smoothly. And regarding the 5% block space reserved to high priority transactions, I'm pretty sure that both ABC and also BU have something similar to this. I'm pretty sure that I've contributed something like that for ABC. I don't know if
it does. It works. It's just disabled by default right now, Andre.
Oh, okay, cool. And then I think that BU have something like that and it is enabled by default. And I have to check, but I'm pretty positive that this is the case.
Well, I mean, what I could do then, if you guys have all the same code, is I could just set the default high priority space to 0% of the block, because that's how it's in the command line, and then it would be the same compatibility with everyone else.
Okay, makes sense.
Yep.
Continue on, Andrea.
Oh, other than that, we are working on other things like improving code base, reducing technical debt, improving graphene, and other things that I don't want anybody to be annoyed with. But yeah, nothing major.
Okay, thank you, Andrea. Any questions for Andrea on this? No? Move on to the next item then. Bitprim, Fernando?
Well, everything is working fine at our side. So we are working, I am working in some internal improvements, like the mempool and mining stuff. So nothing to report regarding the update.
All right, thank you. Any questions for Fernando? Hearing none, we'll move on to, oh, we don't have anybody here from BCash. Anybody have any update on what's going on with BCash?
So I have a minor update just because I was reading it online. It looks like the patches that were done for BCash did work. They were able to sync the chain after the fork, and it did go through the fork just fine. However, I'm not sure if that PR actually merged. I know that it was up and that branch worked, but I don't know that it successfully merged into mainline yet. So if anybody is running BCash, they should just check whether or not they should be using the branch that was set up for the fork or master, depending on the merge status of that PR.
All right, thank you for that, Josh. We'll move on to the potential items for the next upgrade on November the 15th, 2019. Seems so far away, but boy, it's going to come fast. So the first item on this is Schnorr for CHECKMULTISIG. And maybe Mark Lundeberg can tell us more about the design considerations, potential issues, and prospects for inclusion in the next upgrade. Just to put you on the spot, Mark.
Yeah. Yeah, so Schnorr activated on CheckSig and CheckDataSig, and that's been running smoothly, and everybody seems happy with it. BCHDs and neutrinos signing by default with Schnorr, so that's pretty cool. But there is one other signature checking operation, which is opCheckMultisig, where you feed in a bunch of pub keys and you feed in a bunch of signatures, and it checks them all against each other with a threshold. And this is what people use for multi-sig wallets typically, although you can also use it inside smart contracts, for example. And ideally, we would like it so that all signatures could be Schnorr signatures if the wallet dev wants to do that. And right now, that's not possible with CheckMultisig. So if you wanted to do Schnorr support, you're sort of in a weird, awkward situation where you have to do ECDSA still on the opCheckMultisig. And it's an interesting upgrade because opCheckMultisig is a really bizarre opcode, the way it works. So if anyone is interested in how script works, there are interesting issues like the fact that you can have public keys in there that are invalid and garbage, as long as they don't actually get checked. As long as you have enough signatures that get checked before it sees those public keys in the list, it'll actually proceed just fine. And there's another issue, which is more of a problem in this case, which is the script doesn't tell the node which signatures go with which public keys. So the node just has to sort of try them all out with each other and see what works. And if it doesn't work, then it says, oh, okay, I guess it failed. But it has to do lots and lots of signature checks. And that's a problem for efficiency, but it's also a problem for doing Schnorr batch validation, which we would really like to be possible. So we're going to have to redesign a little bit how this opcode works for the Schnorr signatures. And there are various ways to do it. It's much more tricky than doing the CHECKSIG. So if anyone is interested in this design, please join in the Schnorr work group. I think there's a link from the BitcoinCash.org work groups list on GitHub. And yeah, so one of the issues we're looking at right now is when we introduce the new way that the script will tell the node which signatures go with which public keys. Is that going to be expanding the list of signatures so that there's one signature per public key, and then you leave an empty spot for the signatures that you don't want to be checked? Or is it going to be where we repurpose the null dummy element? And this is getting into the next item that we're going to talk about. We could repurpose that as a bit field maybe. So there are interesting considerations there, like smart contracts that depend on how many items get consumed from the stack. Yeah, so if anyone is interested in smart contracts script, yeah, please get involved. I think it'd be really good to have input from various people on this topic.
Thank you, Mark. I'm sure no one has any questions for Mark at all. Are there any questions for Mark? I was being facetious. Well,
that bit field you mentioned, that would just basically tell the opcode that some signature didn't exist, and just to check skipping, just to skip checking that particular pub key signature. So you'd still have to provide them in a particular order then.
Yeah, yeah. Yeah, it would still have to be in the right order as it is now, but you would have a mask that says, okay, this one yes, this one no. Yeah. So.
And then you could, instead of having the null dummy requirement, you could have a null dummy, or it is like a bit field that is exactly the right number of bits for the number of signatures you have, with everything on or basically.
Yeah, I'm still thinking about it. The bit field issue does have other issues, like it's more complicated to work with that. So
I'll ask you offline.
So I have a minor question, which is for people that have put together a multi-sig transaction and maybe have it saved or time locked or something that would happen before the upgrade, how would changing the definition of that opcode affect legacy transactions? And how do we make sure we don't brick transactions?
Yeah, so one of the design considerations is to make sure that when you do spend with ECDSA signatures as a normal, that it works the same way. Like that's pretty important. You don't want to break wallets or smart contracts that are doing the usual thing. But there are some smart contracts that may do unusual things. So that's where it gets more tricky. Yeah.
Any further questions for Mark?
I guess I don't know if Mark mentioned, but he has a draft specification up on his GitHub. So I've been kind of looking through that to try to figure out how it works. So that's maybe a good place for people to start if they want to figure out what's going on.
Great. And we'll get that link up with the show notes on this for today's presentation. Moving on then to the next item, which is null dummy. Who would like to start off on null dummy?
I guess I can mention. I mean, I guess it relates to what Mark just said, but I've been kind of looking at getting it in there. It would be pretty simple to just implement it as it currently is in the code, just to start enforcing it. So I've kind of had that on my to-do list, but I guess maybe I should wait to see if it looks like we're going to want to repurpose that or not. I don't know. But I think in general, it's a pretty simple thing to do, but just make sure that like, for people who don't know, in CHECKMULTISIG, I guess the way it's implemented, there's just this extra element that has to be on the stack. And right now it can be anything, and it doesn't, the code doesn't do anything with it. So that's a way that, since you can put anything in there, it's just a source of malleability. Like someone could just change what's in the dummy element, and it doesn't affect anything. So NULLDUMMY just says this has to be 0. And if it's not 0, it says it's invalid. Yeah, it's just one of those weird quirks in the script.
So for the non-technical audience, can someone give just a high-level overview of what NULLDUMMY is? I think it's obvious to a lot of the developers, but a lot of other people.
It's nothing that interests the non-technical audience, to be honest. Like, it's just like none of your concern. It doesn't change anything to you in any way, shape, or form, unless you're looking at how the transaction are built, which at this point you are a technical person.
Amaury, do you want to introduce yourself?
Yeah, I'm the guy who was late.
That's true, you were late. Okay, so Amaury, as people know, is the lead developer for BitcoinABC. Thank you. Anything further on NULLDUMMY? Moving on to the next item, minimal push in scriptSig. Who would like to take on this one?
That's me again, I guess. So right now we just talked about the malleability with the null dummy element. So you can mess with this dummy element and change the transaction ID. You can invalidate like child transactions. And right now, I think only really miners can do this. So it's kind of a niche issue, but it is a concern if you're doing like off-chain transaction chains or something unusual. And there have also been concerns in the past about like services being attacked with this malleability changes. So so what we call this minimal push rule. So basically any data that you push inside of the script, that's like in the scriptSig, which is the unlocking script, they can be pushed in a variety of ways, and right now all of them are valid. And yeah, every time you change one of those things, it changes the transaction ID. So basically the idea is to just stop this, just to require that whenever something gets put on the stack, it's pushed in the minimal form. And this only has to be done for the scriptSig, the unlocking script, because the locking script is already fixed. You can't change that. That's not malleable. So yeah, it's a pretty simple rule to describe, but yeah, it just hasn't been implemented yet.
I guess the one issue that I just like for this audience is like, right now there's a flag in the code called minimal data that enforces also minimal data pushes, but it's a bit more, it covers more than what we really need to cover. So I think that's something where we should decide what makes the most sense to do. Like one option would be, let's say like, okay, we're just going to enforce that flag. It's already in the code and so on, but it does a lot more. Like it makes sure that all the data, like all the numbers that go into opcodes have been pushed in minimal form. And I don't know, I think it might cause it's not really, it might be more than what we really need to do. So like Mark was saying, like just having the minimal push in the scriptSig might be the more modest thing that actually like deals with the malleability that we care about. I don't know, does that make sense? It's hard to explain.
So the difference there is that you could invalidate some existing like pay to script hash transactions if you enforced the current rule as part of consensus rather than
I think that's the worry. That's like one of the worries, like because there could be like non-minimal data pushed already in redeem scripts or something.
They are non-standard though right now if you do that, so they're not really supported very well. But
It wouldn't be able to tell, right, if it's in the redeem script.
Oh no, it'll like what happens right now if this minimal data flag is on, which is it's on when it does the standard check. It checks every push opcode. It doesn't matter where it is, if it's in the locking script or the unlocking script, and it enforces that to be minimal. And whenever something is taken off the stack and interpreted as a number, it also enforces that that's encoded in the minimal form.
So you could pay to a script hash that then would require you to broadcast a non-standard transaction?
Yeah, you'd have to get a miner to do it for you. Yeah. But so I just think it's kind of odd that, as Antony was saying, it sort of mixes up these two concepts of, one is how you push things onto the stack using this like script language, and then the other thing is how are numbers interpreted when they're taken off the stack. And these are two very different things in two different spheres of the script, and yet they're like under one flag and kind of conflated. So it would be rather, I think it's maybe a little bit dangerous to make that the consensus rule because it affects so many things and there are many implementations. I don't know. That's my concern there.
Yeah, like it seems like it would be better to just enforce it in the scriptSig as like, because that's a more modest thing, and it actually solves the problem.
Yeah.
But yeah, just like just so people are aware of all that stuff.
One question there. For pushing the redeem script itself, would you still enforce it, or would you?
Yeah, that's a push in the scriptSig, so that has to also be pushed minimally, whatever the content of that is, whatever that byte string is, Yeah.
But that does have an effect on the hash of the thing, right?
Oh yeah,
it might be something. Yeah. Anyway.
Yeah, so that one can be pushed minimally if you want to fix malleability for that. And by the way, so the effect of this is due to all the other malleability fixes we've had so far, this would make paid to public key hash transactions non-malleable, like all of them. So that would be pretty good. That's like 90% of transactions. I know there are other chains that have other malleability fixes and they're only like 40% of transactions. So yeah, it would be pretty good. NULLDUMMY would fix like 9% more, so 99%, let's say. That would be pretty awesome, I think.
Pretty close to 100.
Yeah.
Okay. Thanks, Mark. So we'll move on then. If there's no further questions on that, we'll talk about Sigops counting and the limit.
I'll take that.
Thank you, Jason.
So Sigops counting is a little bit of a complex topic. It affects multiple parts of counting transactions and blocks. Just as a quick overview, Sigops is a way of kind of providing a heuristic or a guess for the computational time of particular opcodes, or executing some calculation that the node needs to do. So for example, maybe op-add is one sigop, and then doing a multi-sig would be maybe 1,000 sigops, something like that. But basically this heuristic, it was kind of implemented in a messy way. It calculates the sigops for transactions in a different way, slightly different way than the sigops limit is calculated for blocks. For blocks, for example, they do kind of this bucketing. Every megabyte that goes into a block has the sigops counted for a limit only in that bucket of 1 megabyte, and then that limit kind of refreshes for every additional megabyte added onto that. So this calculation, being kind of wonky, needs to be refreshed, redesigned so that it's consistent across the entire code base. Hopefully easier to reason with. And this is something that has become a little bit more important in our minds in the recent past. The vulnerability that I brought up just a few minutes ago, that was kind of based in this code. So due to its complexity and some parts that we missed in other prior parts of the code, it really does need some attention. If we can fix it across all the implementations, then we no longer have to worry about discrepancies in sigops counting. And it also gives us a chance to kind of improve the way that Sigops are counted, because right now the heuristic is not very scientific. They're kind of just numbers that were pulled out of the air, and there are known ways to generate transactions that their computation time greatly exceeds what you would guess they would be. So, normally we want transactions to be validated as quickly as possible, but it is possible to generate chains of transactions that take, seconds to validate. And seconds in the node world is a very, very long time. So it's something that we'd want to look at seriously limiting, because then otherwise it's a DOS vector. So that there's a lot of thought that needs to go into how the new counting scheme should work, but it's something that we want to look into for the next upgrade.
Any questions or comments to Jason? Mark?
Yeah, I think we fixed the worst DOS vectors were fixed though when the new sig hash algorithm was adopted, right, with the quadratic sig hash problem. So that's gone at least.
Yeah, the worst one has been solved, but there's still. My understanding is that there's still some other. They're not really exploitable per se, but you can still generate very, very expensive to validate transactions. And when you look at it kind of from a farther back perspective, you kind of go, oh, these Sigops, it seems like they would be calculated at a higher number for this particular transaction, but they're not, because the whole calculation is very naive.
Yeah, there's an interesting comment on this I just want to make, which is I was looking in Bitcoin Core code base, and they have this Satoshi per V bytes. I don't know if people have ever seen this, but this V bytes or virtual bytes or whatever it counts as, it counts the transaction, it counts the witness data, but it also counts the Sigops, because they also have a Sigops limit, which is a hard limit per block. So because they have this additional resource constraint per block, well, you have to pay for that as well. Not just for consuming block size, you have to pay for consuming Sigops. So I just thought that's kind of an interesting thing. And yeah, if we could get rid of the limit per block, maybe that would be nice. That would simplify the way to reason about which transactions can go into blocks or not, that sort of thing.
Yeah, it's hard to say at this point if we can remove that limit entirely for blocks, but
I was thinking a per transaction density limit or something would be nice.
Yeah, it's possible, depending on how we end up tackling that problem.
Yeah.
Either way, we want it to be drastically simplified, because then it can be better reasoned about, and then we can determine whether or not these limits are actually reasonable to have in the first place.
I mean, I think from my perspective, like, it's not what we want is not really complicated. Like, you just want to count the number of signature checks that are actually executed. Like, so that's really not, in a way, that's really not that complicated conceptually. It's just a matter of how it does it now is so screwed up, and transitioning to it, you don't want to like make any, like, it's just a bit of a, like, the transition to that is complicated, basically.
Right. Yeah, I think the transition is far more dangerous than coming up with an ideal design.
Yeah. So I mean, I guess it seems like the way forward would be to try to implement counting the correct way, just but not do anything with that number at first, and then see how that goes. But yeah, yeah, like, conceptually it's not that complicated. It's just like, I guess the signature checks are like 1,000 times more costly than everything else. So all it does is count. All it should really do is count how many signature checking operations you do. So yeah.
Okay, thank you, Antony. If there's nothing further on Sigops counting, we'll move on to possible NW opcodes, op reverse, reverse op roll, op mul, etc.
I think that was misspelled from new.
Yeah.
Oh, typo. I'll have to talk to my typist on that for sure. Possible new opcodes. Yes, let's go with that. Who wants to lead this discussion? Nobody. Okay, good. We'll move on. Sorry, just kidding. Anybody want to talk about the new opcodes? I know there's been some discussion online about it.
Yeah, I guess there's been some discussion online, and various people have ideas about it, about things that would be good. I don't know. I mean, I guess a good thing to think about is just what to suggest to people as like a path forward for this, because I mean, personally, I don't think just throwing in random opcodes as people feel like it is necessarily the best way to design the system. So, like I know, for example, that Peter Willa had mentioned something about doing reverse op roll in a talk, which apparently is like when you analyze like when you compile some kind of language into the script, that's a big gap. And like if you go back and look at the old fork literature, they mentioned like there's people who've looked into how the most efficient way to compile stuff down to a script. So yeah, I don't really know what to suggest other than maybe some people should like start trying to look into the research behind like how to design a good scripting language and what the gaps are, or what's needed to like efficiently compile stuff down to smaller scripts. I don't know if anyone has suggestions. I guess just I would ask like, does anyone have ideas on like what people should do for this stuff, or suggestions?
Well, to kind of add to what you said, I agree. People need to focus on, opcodes that are valuable, essentially, or novel. We don't want to just be throwing in a bunch of opcodes, because every time we add complexity to the system, it's something that needs to be maintained forever. So it's not necessarily a good decision from the engineering side to just go, oh, hey, this opcode is a great idea, let's add it. We kind of have to, look at can other opcodes be used in its place? We don't really just want to be throwing things at the wall and seeing what sticks, because that's not really how the protocol development should be going. Personally, I want to focus more on the scalability issues. I'm a little less interested in the script, adding new opcodes to the script system. But if someone comes along and says they want to add something that is particularly novel, useful, solves a particular problem that the script system doesn't, then I am interested in reviewing that. So as long as they do their research and put up a draft, then we'll take a look.
Jason? And Shay, you had a comment as well?
Oh, the author of Spendin might be a good person to bring into the discussion and sort of invite to participate and provide whatever data he has. Because he has that other smart contract language that compiles down into Bitcoin script. And there are some cases where he's noted that he has to generate very long scripts to do otherwise simple things.
Yeah, I've talked with him a bit about this. He seems like he's fairly sure it would be useful, but he wants to do more research. So I think I'm really interested to hear what he comes up with. But
when you're talking about a specific thing now, I don't.
About the reverse op roll.
Oh,
and yeah. Just to clarify, so the reason you want a reverse op roll, it's not that you want to roll the stack in reverse. It's not like that's the point. The point is right now there's no way to insert an element into an arbitrary depth in the stack. You can take elements out from an arbitrary depth, but you can't put them in. And the reverse op roll would be just one way to do that. It doesn't actually have to be roll opcode. It could be something else similar, but yeah, reverse oppic, I guess, I don't know, opput or something like that. But yeah, so that's the reasoning behind this. That would help a lot with scripts. Yeah.
Thanks, Mark. Anything further on the possible new opcodes?
Yeah, I guess I agree with what Shammah said. I think there's also like, there's a few of those scripting like languages. I think there's another one, I forget. I think Bitcoin.com was working on one also. There was a fellow, Roscoe, who did something similar. So yeah, those like, it would be good if those guys like put some thought into this, or maybe look up the research on this kind of stuff.
Well, when we have the recording prepared to be sent out, we'll make sure it gets sent out to people that are mentioned in it as well. Nothing else on possible new opcodes. We'll move on to 25 unconfirmed transaction limit. And this was originally going to be set up as a discussion with Shay and Emil, but Emil's not here right now. Shay, do you want to take this?
Yeah, sure. So right now, the node will not relay any transactions that have that are like a child of a chain that's greater than a length of 25. That's actually minor configurable. As far as I know, it's not a consensus parameter in any way, so a miner can choose to increase that limit. However, there's a lot of computation that has to happen on these chains of transactions, both while they're mined and as they enter the mempool. So the node right now tries to do what's called child pays for parent. So if somebody gives you a transaction that has a very low fee, such that it may not get confirmed very quickly, you can then spend that transaction with a much higher fee, and the spending transactions increased fee will count alongside the parent. This makes sense for miners in a case where there's like full blocks or a fee market or something that we don't have, because they can make more money if they include a low fee parent and a high fee child than maybe including some other set of transactions. But recalculating as you add new children constantly has a complexity of n factorial in the chain length. And then every time a new transaction is also added to the block, it has to recalculate the package fees of the new groups of transactions that are generated when something's removed from the set of possible inclusions. And so this gets really expensive while mining as well. So just removing that limit is actually not good, because someone could easily generate a chain of like 1,000 transactions or whatever the limit is, and now suddenly both creating and validating blocks can take over a second, or adding to the mempool starts getting very expensive as well.
I think it doesn't affect the validation. Just sorry to jump in.
It does right now, because the calculations have to be done in topological order. You can't just remove everything from the mempool. You have to do it in reverse topological order in order to maintain the fee calculations properly. Because when you remove something from the mempool, it has to go through and update all of the child transactions fees, their package fees. And if you were to remove something from the middle of it, you would break that chain and you wouldn't be able to recalculate the package fees properly. Even though you might remove like the whole front piece.
Blocks, but recovering the mempool after validating blocks, basically.
Yeah, you either have to recompute everything or you have to do it on the fly, and both of these things end up being expensive. So one option is to just remove child pays for parent entirely, and just basically make sure that your blocks are valid in canonical order. And also that gets rid of the topological requirement as well. But there are some cases where it may still be worthwhile to have child pays for parent. So if miners have a minimum block fee of greater than the minimum relay fee and somebody sends you a transaction, you'll want to be able to spend that from the mempool. So you still want to be able to have some limited form of child pays for parent. Doing this at a depth of 1 was considered in the past, but if you do that, someone can simply generate a chain of 2 transactions and then basically prevent you from confirming the whole chain as well. So that's not a great solution to just make it a depth of 1. So I have a patch up right now that decouples the mining code from the mempool code entirely, so that all of the fee and package calculation is done while getting the block template. And basically what it does is it calculates how many ancestors each child transaction has, in order to simplify the computational complexity. It may recount some parents double if you have a diamond-shaped graph. So somebody spends a transaction into 2 different transactions and then spends those 2 other outputs back into another transaction. It's a really rare case. Like, you would have to intentionally build chains of transaction that way, and be sending them all to yourself. And in that case, it'll just double count some of the ancestors, which is not important, right, for the topological requirement. So it counts all of the ancestors for all of the transactions, and then it basically adds them to the block in that topological ordering that is generated from that by fee. But then there's one additional thing that happens is it's explained in the actual patch, but it goes through and it adds fees in a similar manner so that the child includes the total size of all its ancestors and the total fees of all its ancestors. And while it's doing that, it keeps track of the maximum sizes and maximum fees. And if its fee rate is greater than the maximum seen package fee rate thus far, while it's calculating all of the data, this is prior to actually adding anything to the block, it resets its topological rank to 0, rather than it being the total number of ancestors, because we know that we can add it and all of its ancestors for the fee rate that we have there, and it be the maximum of any of the packages thus far seen. Hopefully that makes some sense. So basically, it resets the rank order to 0, and then you're able to sort by fee and just add everything to the block.
Let's just check in with that, Shay, and see if there's any questions on what you've said so far. No? Sounds like people have got it.
Okay.
I guess I just had a question. Like, so the way this all works, I guess this would have to be, like every implementation would have to do this the same way, right? So that if you wanted zeroconf to work properly, like
not really. This is all done at mining time, so it would have some impact on, I guess, how blocks well, no, not really, because people are still going to have synchronized mempools under the same conditions they have now. The only thing that nodes would need to do differently is stop accepting transactions based on their package fee rates. So you would just accept transactions individually into the mempool based on the min relay fee still per transaction. But that's not particularly new though, right? Because as you added the first transaction, it has to individually meet the minimum relay fee. And then the child, like, it can't pay for it right now because it's either already been rejected or it's already in the mempool.
I think actually that's not totally true. I think that you can have sub 1 Satoshi per byte transactions that you send, and then they get put in the orphan pool, and then when the child comes in with a higher fee rate, they can get pulled out of the orphan pool right now. I think that happens, which is...
I'd have to double check because I don't believe that that's the case. Although
maybe we can get an update next time round. We'll have a meeting in a couple of weeks and then see where things lie with the unconfirmed transaction limit at that point. Just the reason I'm looking at the time right now, we do have another question that's come in. This is, I'm going to send the question to the panelists and I'm going to read it. It says, I would like to see a simple consensus change to make the transaction version B correctly. Since we don't have greater than 2 times version, forbid higher versions. Rationale is that upgrades to transactions in future become easier. Anybody want to tackle that?
That's a good idea.
Okay. Any further comments on?
The only question I have is anyone aware of wallets or any other node software that uses greater than version 2? Because I know it's not enforced, but does anyone even use software that does that? Is anyone aware?
I've never seen that. No.
How does this make things easier if there's already existing transactions with that in the blockchain?
Because you won't have any in your mempool.
Could it just be a standardness rule then?
Yes.
It's kind of weird. I don't know why that's not enforced already. I'm surprised we didn't inherit something like that from Bitcoin Core. Interesting.
Well, because the version fields are more or less useless the way Satoshi implemented them.
Yeah.
They are in none of the place where you can do something useful with them, so they ended up just not being used at all.
Only thing I think of someone like abusing that field would be if they were looking for a field to grind on to try and target a particular transaction ID. But there's other fields you can grind on too.
Yeah, just grind your signature also, yeah, something like that.
Okay, I'm just going to have a call for any other questions from the attendees. And then I think we'll probably just see if there's any other comments or items that you, the people here as the panelists, would like to bring up. Going once. Going twice.
I did have one question for Andrea.
Thank you, Josh.
So I was curious, I've been trying to figure out a way to get the neutrino BIPs across full nodes. And I was looking for a BU dev that might want to tackle adding that support to BU. Do you know who I should be talking to see who would be a good candidate to do that?
I guess that Peter Chipper is the right person to talk with.
You got that, Josh? Peter Chipper?
Yeah.
Yes.
Okay, great.
Even Greg Griffith, but Peter is the one that usually deal with this kind of that part of the code.
And Josh, I believe you're on BU Slack, so you shouldn't have any trouble locating him.
Yep, sounds good.
Okay, thanks. We had one more question that's just come in from the audience. What happened with the transaction size limit, 64 bytes instead of 100? Anybody want to take that?
Looks like there is a huge demand for transactions that are between 64 byte and 100 byte. It's crazy. Everybody wants to do that.
I know peers do, like Chris Pacia. That was one of the issues with your get block template, right? You're running into that problem.
I just wasn't padding the Coinbase properly. It was like an off by one bug.
Okay. Oh, the padding, yeah. Okay. Yeah.
So has the question been answered sufficiently?
But why it didn't get in for this upgrade is, well, nobody did the development work on that, so it didn't happen.
Okay.
Yeah. And perhaps on that point, if anyone does want something in the November upgrade, remember that August 15th is going to be the feature freeze date, I assume, based on last time. Is that right? Yeah. And that means the feature has to be well tested, activation code, everything done before then. So.
And a spec with rationale far before that.
Yeah. So get on it like right now and work very hard if you want something. If you want something done. I just have to say that. Yeah.
Okay. Well, I hope that answers the question. We have no further questions at this point. I'd like to thank you guys all for attending. If there's no further remarks, we'll move on and see you guys in a couple of weeks. So,
Sounds good.
Everybody.
thank you very much.
Bye.
Thanks for the
Bye.
invite.